Students, welcome back. We were doing series solution of differential equations, and when do we require series solution? When the ordinary kind of solutions which we obtained as functions cannot be obtained. Now let us do a short recap of what we did in the part A of this lecture. So if we have a differential equation of the form y double dash plus a function of x into y single dash plus another different function of x into y is equal to 0 if it's of this form, but it doesn't mean that this has always to be different. It may be the same one also, but we call px the function with which y dash has been multiplied, or the coefficient of y single dash, and qx is the coefficient, the x function which is a coefficient of y. So in this case, first what we do, we look at px, see if it's analytic at the particular point. So I want to find whether the function is ordinary or singular, or what kind of point at x is equal to x naught. So what I do, I put x is equal to x naught in the denominator of px. If this is equal to, if the denominator of px on putting x is equal to x naught gives me equal to 0, the denominator, then it's not analytic at x is equal to x naught. Then we say that it's an ordinary point. It's not ordinary, a singular point. But if this is not equal to 0, we say it's an ordinary point. So that is an ordinary point and a singular point. Once again, ordinary point is the one for which x is equal to x naught does not give a non-zero, does not give a 0 denominator. But then if at x is equal to x naught, this denominator gives me a 0 value, then it's not ordinary but singular. So if it's a singular, we have to again check what kind of singular point it is. What is x is equal to x naught is? That is, for this differential equation, x is equal to x naught, we can obtain by finding that it's not analytical here. But now to find out whether it's an ordinary singular point, or not ordinary, regular singular point or irregular singular point, can be found out by doing another exercise, that is by multiplying px by x minus x naught and multiplying qx also now by x minus x naught square, and the resulting two functions are analytical at x is equal to x naught, then we say it's a regular singular point. I hope I have not confused you all I have not jumbled everything up for you. So let's do one thing, let us do an example so that things become clearer. So, example. Examine whether x is equal to x naught is an ordinary or a singular point. Of twice x squared d2y dx squared plus 7x x plus 1 dy by dx minus 3y is equal to 0. So students, first let us do one thing. Let us name this one and let us compare it with the equation that we had taken to understand what was the ordinary point and singular point. So in that equation we had like this: y double dash plus px y single dash plus qx y is equal to 0. So what do we do here? We try to convert this into this form. So here we have no coefficient of y double dash, so we have to divide each term by twice x square. So what do we have here? This becomes 7x by x plus 1 divided by twice x squared y single dash minus 3 divided by 2x squared y is equal to 0. So see, now we have this as p and this as q. Both are functions of x. So we can write them as p and q in this manner. So we can do as this as 2. So we can write here comparing with 2. That means comparing this particular equation with 2, px is equal to 7x into x plus 1 divided by 2x squared, and qx is equal to 3 divided by 2x squared. This is what we get. There should be a minus sign here, so this will come like this. And now let's clear the board. Clear the board. So what I have to do here now? What was my point? My point was at x is equal to 0. So that means x is equal to 0. We have x equal to x naught, so here x naught is 0. So at x is equal to 0, what happens to px? So we find that px, what was px? X was by twice x, 7x, 7 into x plus 1 by twice x. So when I put x equals 0, the denominator becomes 0. So I call this as undefined. So this is undefined. Now let us look at qx. What is qx? Qx is equal to 3 by 2x squared. Here too, when I put my point, they were asking us whether it's singular or ordinary at x is equal to x naught. So this is the point of consideration. So when I put it like this, what I get here also, when I put x to x square in the denominator, this becomes undefined. This is undefined. Actually, I can't really write this as this like this. I'll just have to say that this is undefined. I can't put a approximate sign like this. So which is undefined, which means that since both of these are undefined, at x is equal to 0, we'll write like this: does x is equal to 0, not at does x is 0 is not an ordinary point, is a singular point. It's not analytical, so it's a singular point. Now to find what kind of singular point, what I have to do now, second, I have already found that it's a singular point. What I have to do, I have to multiply px by x minus x naught. So what was my px? Here it is 7x plus 1 divided by 2x. So when I multiply it like this, and what is x minus x naught? X naught is 0, so it will be just x. So this I can cut, this get cancelled with this, so I get 7x plus 1, which is defined. And similarly for qx into x minus x naught, I have to do this and see whether it's analytical or not. So qx is 3 by 2x squared, and what I do, this should be square here, so it is x minus 0 square means x squared. So again this is also analytical, so you see it's defined, and so this proves that yes, it's a singular point, but it's an ordinary singular point. So this is a, I find very difficult to manage this board actually, and so we find that thus x is equal to 0 is an regular singular point. So this is a regular singular point if this is defined like this, but then if these two would have been undefined, that means its denominator would have become 0, then it would have been an irregular singular point. So this is these things might sometimes come as short questions, and so this is how you do it. And from our next class we'll start the series solution, power series solution of differential equation. This is just the background actually. These things usually don't come in the examination, so I'd like to stop here.